Okay, in 12.3, we learned measures of central tendency. So again, that was one number that you think best describes the data. In 12.4, we're going to learn measures of dispersion. Measures of central tendency only gives us one thing. In statistics class, the actual stats class, what we look at is two different data sets that are way different, but they have the same mean. So then we say, okay, we need more information to determine what it is about these data sets that make them so different. So we learned two different things called measures of dispersion. This means how spread out is the data. So the first one, there's just two of them this time, is range. And what that is it's your highest value minus your lowest value. So that one should be pretty simple. Okay, so the range tells highest value minus the lowest value. So in that example, in my stats class, the mean was 35 for both of them, I think it was, but the range for one of them was like 55 and the other one was only 20. So there's a huge difference in how spread out the data was. So that's what you're looking for. Range means how spread out the data is. So you take the highest value minus the lowest value. The next one is much more complicated. Those of you that take stats, this is where you're going to learn a different formula for this, but this is the formula we'll use in this class. It is something called standard deviation. Okay, so we're not going to do a whole lot with it necessarily other than calculate it, and then in 12.5 we're going to use it for something. But what standard deviation does is it tells you the average, I shouldn't use that word, but there's a reason, the average distance that the data values are from the mean. Okay, so technically I should say the mean distance that all the data values are from the mean. What that means is if you were to take and put all the data values on a number line, and then look at how far away from the mean they are, then you find that average, and it will tell you that. Okay, so there's a formula that you're going to use, and it's going to look really scary, but I'm going to work it all out for you. So standard deviation is a little s. What you have is you have a square root, so it's a big square root. Okay, on the top of your square root, you have this weird looking e, and then x minus x bar squared. That's all on the top over n minus 1. This formula is on page 761. If you don't want to try to read it from my notes, it's on page 761. Okay, so let me break this down for you and then you'll see an example. First of all, x bar is the mean. So we didn't talk about that in 12.3, but when you see x with the bar over it, that is the abbreviation or the symbol that represents the mean. So you have to calculate the mean in order to do this. Okay, this weird looking E tells you to find the sum. It's the Greek letter sigma. Okay, those of you who have taken pre-calc have seen it. But what it is it tells you to find the sum. So what this means, and again, we're going to work through this, is you take each data value minus the mean, and you square it, and then you add it all together. That's what this whole top part means. The sum of each data value minus the mean squared. The reason we have to square it is because distance can't be negative. So there's the absolute value, but that doesn't really work when we calculate them. So you have to square it. That's why we take the square root in the of the whole thing. The denominator has n minus 1. N is your number of data values. Okay, so these are the only two things you need to know from 12.4, but obviously working through this is going to be a little bit tricky. You will not have to memorize this. I'll give you the formula, but you're going to need to know what the formula means. Okay, and I'm going to write out a whole chart. Some of you will decide you don't need to use the whole chart. You're going to have to decide what works best for you. Okay, so to practice, we are going to do, if I can find it, page 763, number 16. Okay, and what this is it gives you how much caffeine is in certain soft drinks. Down here in Florida, they call it soda. So that's kind of hard to get used to. So I'm going to make this chart. First, I'm going to put all of our x's, and then I'm going to put x minus x bar, and then I'm going to put x minus x bar squared. And again, I'll kind of show you, some people skip this middle one, and we'll talk about that. You don't have to put these in order if you don't want to. I'm not going to, but it's totally up to you. So 37, 43, 25, 80, 55, 33, 40, 40, oh no, 40, 30, and 35. Okay, so those are all the x values. So to find the mean, remember that's x bar, you add those all together, and that should give you 378 divided by 9, which gives you 42. So again, that's just the mean. So even though it doesn't ask you for the mean, you have to give the mean, or you have to calculate the mean, because you have to take and subtract each one of these. This number minus the mean. So I usually write my mean up here, 42, so I know what it is. Okay, so 37 minus 42 gives you negative 5. 43 minus 42 gives you 1. 25 minus 42 gives you negative 17, so on and so forth. So all you're doing, again, is you're taking x, whatever your x values are, minus 42, because that's what your mean is. Okay, so 38, 13, negative 9, negative 2, negative 12, and negative 7. Okay, so again, what this means is if you were to draw out a number line, 42 would be your mean, 37 is 5 to the left, 43 is 1 to the right, 25 is 17 to the left, so on and so forth. Okay, then what we need to do is we need to square these numbers. You should hopefully remember that anything squared has to be positive. So this is going to give us 25, 1, 289, 1,444, 169, 81, 4, 144, and 49. Okay, so I will be honest, most people skip this whole thing and just type in the calculator. So all you need to do is type in 37 minus 42 squared, hit enter, and it will tell you 25. Then you can go back and change it to 43 minus 42 squared and get 1. 25 minus 42 squared and get you 289, whatever. So don't feel like you have to do this column. All right, most people, I would say, some don't even write this down. I do just because I like to see it. So most people only write these two columns, but it's up to you. Okay, but these are the numbers then that you have to add together. So the sum of x minus x bar squared is equal to all of those numbers added together. And that should give you 2,206. Okay, so again, it's up to you what you write in your chart, but these are the numbers you have to add together. Calculate your mean, take each number minus the mean and square it. Each number minus the mean, square it, so on and so forth. Add those all together. That's what the top part of your formula says. All right, so the actual calculation for standard deviation is going to look like this. S equals the square root of 2206 over 8. Now, where did the 8 come from? The formula is n minus 1. If you write 9 minus 1, you're going to have to put it in parentheses. So that's why I just subtract it in my head. Okay, so you can type this all into your calculator. And we're going to round, since this is, let's see, the directions in the book tell us to round to the nearest hundredth. So this is approximately 1661. And again, I know that doesn't really mean anything to you. We're going to use it for something in 12.5, but in actual stats class, we learn a lot more what that number means. But again, it's the average distance that the numbers are from the mean. So again, this is 5 to the left, this is 1, 17, 38, so on and so forth. So it doesn't work out exactly, but basically if you would average those numbers together without the negatives in it, it should be approximately 16.61. All right, the other thing is the range. So for the range, you need to take your highest number, which is 80, minus your lowest number, which is 25, and you get 55. Okay, so for 12.4, all you need to know is S, which is your standard deviation, and your range. Okay, so I know this formula looks really, really scary, but it's not too bad once you break it down. Again, calculate your mean, take each number minus the mean and square it. Then you add all those together. That's where this 2206 comes from. You have to take the square root of that number divided by n minus 1. So there were 9 data values, so that's why I divided by 8. All right, so only 2 problems to practice because I figured if you can do 2 of them, you should be fine. So on page 763, just 15 and 17. They're very similar to this right here.